Welcome again to Benchtop Chemistry. So far we learned about what are quantum dots. These are the nano-sized particles with all dimensions including length, width and height falling in the nanometer scale of measurement. Today we'll see how these quantum dots can be of any importance to us as an engineer, an entrepreneur, a researcher or an industrialist. One of the applications of quantum dots is in display technology advancement. Quantum dot light emitting diode, that is LEDs, are one of the most promising self-emissive displays in terms of light emitting efficiency, wavelength tunability, and cost. Quantum dot displays are not only brighter but also they offer prolonged screen life, reducing the electronic waste. Quantum dot LEDs can cover a range from a wide color gamut and large panel displays to virtual reality displays, wearable or flexible displays, automotive displays, and transparent displays which demand extreme performance in terms of contrast ratio, viewing angle, response time, and power consumption. They show 90% increase in color vibrancy as compared to the traditional displays, and so lately longevity and inkjet printing of quantum dots LEDs are being tested for future sake technology. Quantum technology is still at an early stage of maturity, but it could eventually have major impacts on both economic prosperity and national security. Seeing the bright future of these dots, many industrial and research institute collaborations have been made lately. In 2017, DIC and Milpitas, California-based Nanoscience announced their collaboration to develop inks for use in production of inkjet printed dot color filters for displays. The global quantum dot material market is projected to reach 550 million US dollars by 2034. Quantum dot enhancement film was introduced in 2013 and are still the dominant quantum dot product today, applicable to both edge-lit and direct-lit displays, lower temperature and lower light flux requirement. Nonetheless, the researchers at Niels Bohr Institute are working to overcome the obstacles in developing a working quantum computer, a pan-European collaboration with French microelectronics developer CEA-Leti. One of the key features of the device is the two-dimensional array of quantum dots. Now, after having this brief introduction about the quantum dots, let's see if all of us are eligible enough to become a good engineer. So I have a short case study in front of you. In the fiercely competitive world of consumer electronics, I actually am a leading television manufacturer, and nowadays I'm facing some challenges. Actually, I want to deliver an unparalleled viewing experience to my customers while reducing the environmental impact of my product at the same time. So, to achieve my goal and get a boon in my business, I now have two main challenges in front of me. Number one, the displays with superior color quality and accuracy, since the traditional LCD screens fall short of delivery vibrant and true to life colors that viewers actually crave for. And number two is to reduce the electronic waste and energy consumptions. I'm sure that by now you must have become smart enough to help me out here. So let's work it out together with the help of our previous video knowledge and the research studies so far. So based on our recent learning, we take quantum dots to offer energy efficient benefits, aligning with my company's sustainability objectives. Taking into consideration this point, actually I did some of the research work and I found that the research also supports the implementation of this solution seamlessly. That means quantum dots can replace traditional phosphors in displays backlighting system, delivering finer breakthrough of 90% enhancement in color precision and vibrancy. Quantum dots also significantly expanded the display's color range, enabling the reproduction of a wider spectrum of colors with unmatched precision. Such displays consume less power, thereby reducing energy consumption while preserving the performance quality. Also, the quantum dots display boast longer lifespans, which translated into fewer screen replacement and thus a win for environmental sustainability by reducing the electronic waste. That means I can now say that my company can successfully introduce such a product that not only delighted customers but also significantly reduced their ecological footprint. Eureka! Thank you for being connected. Stay with me to get more updates on nanotechnology, to get more updates into newer fields, and don't forget to subscribe the channel.